Hello students. So today we're going to discuss about the area bounded by two curves. The area enclosed between the curves of function fx and gx is given by the formula area is equal to the integral from a to b fx minus gx dx. So let me explain this, how this came about. Let's consider that you have the graph of fx which goes like this, and you have the graph of gx. Let's consider that gx goes like that. So the area included between these two curves is this shaded part. So this is the lower limit and this is the upper limit. How do you find the lower limit and upper limit? Here, for this case, when you are having two functions and you want the limit of integration, you will simply equate these two functions f, x, and gx, and then you get two values a and b. So basically, when you are having the area included between two curves fx and gx, the area is equal to integral from a to b, then fx minus gx, then dx. You simply take the area of the upper curve of the region, this one, and the area of the lower curve. If you take the wrong order like gx minus fx, you have the area with the negative sign, and the area with the negative sign doesn't exist. So you simply put it under absolute value. Let's do an example. Find the area of a region included between fx is equal to x squared plus 2 and g is equal to negative x squared plus 4. Let's make a rough sketch of these two parabolas. We have fx is equal to x squared plus 2 and gx is equal to negative x power 2 plus 4. So basically this one is a parabola which turns upward because of the positive sign which is here in the term of x squared, and its minimum point is 0, 2 is here, 0, 2, and it goes upward. And another function gx, it is turning downward because of this negative on the term of x squared, and its maximum point is 0, 4, then it comes downward. So this is our region. So we need to look for the limit of integration, the lower limit and the upper limit. We simply equate these two functions and then we solve. We look for the point of intersection. We equate x squared plus 2 is equal to negative x squared plus 4, which means that negative 2x squared, when this comes there, is equal to negative 2. X squared is equal to 1, x equal to plus or minus 1. So our lower limit is negative 1 and our upper limit is 1. So the area is equal to integral from negative 1 to 1. Then the upper curve of the region is this parabola which turns downward. It is negative x squared plus 4, then minus the lower curve of the region is this parabola which is turning upward, x squared plus 4, then dx. So our area is equal to the integral from negative 1 to 1 of negative 2x squared plus 2, then dx. Area is equal to negative 2x power 3 over 3 plus 2x from negative 1 to 1. Our area is equal to negative 2 over 3. When we replace just 1 which is the upper limit. In the antiderivative, you get negative 2 over 3 plus 2, then bracket minus, let's replace the lower limit in this antiderivative. We get 2 over 3 minus 2. So our area is equal to negative 4 over 3 plus 4. When we make the LCM, we get 3, then negative 4 plus 12, which is equal to 8 over 3. Then we put square unit. Basically, this is the final answer for this example. Let's do another example. Find the area of the region included between the graph of function y is equal to x squared and y is equal to x. Here we have the parabola y is equal to x squared and the straight line y is equal to x. Let's make rough sketch of these two functions. We have a parabola and a straight line. This is the region. This is our x squared. This is our y is equal to x. So how do we find the lower limit of at this point and the upper limit? Those are the values of x. So we simply equate x squared is equal to x. We have to find the point of intersection between these two curves. So x squared minus x is equal to 0. X into x minus 1 is equal to 0. X is equal to 0. X is equal to 1. So those are the limit of integration. So our area is equal to integral from 0 up to 1. So the upper curve is that straight line in that region is x. The lower curve of the region is x squared. Then dx. Area is equal to x power 2 over 2 minus x power 3 over 3. Then 0 to 1. Our area is equal to 1 over 2 minus 1 over 3, which is equal to LCM is 6. This will be 3 minus 2. So the area included between those two curves is equal to 1 over 6, then square unit. So this is the final answer for this second example.